Welcome to this video lesson, which is the full solution to the practice questions from lesson 18.1, which is plane introduction, which focuses on parametric and vector equations of a plane. In part A of our first question, we were asked to determine the equation of a plane containing points A, B, and C. Well, let's draw 3 points randomly in space. We're going to have point A, which has coordinates 2, 6, and -5. We're going to have point B, which has coordinates of -3, 1, and 4. And we're going to have point C, which has coordinates of 6, -2, and 2. And we're going to get a plane that contains all of these points. So this plane, I'm just drawing a part of it here. It extends infinitely in all directions. So in this direction, and this direction. I'm just going to color it in so we can kind of see which direction it's moving in. But that's just a part of that plane. Well, to figure out which way, or the equation of the plane, we will need two vectors that are on the plane, which tell us the direction of the plane, and we need 1 point. We can choose any of these. I'm going to choose A, and I'm going to choose vector AB and vector AC. We know that these two vectors, we're hoping that they're non-parallel, and we can check that later. If they are parallel, we'll notice as we're writing the equation. And we need the point, which we can just use point A for. Okay, let's come up with our two vectors here. We are going to use vector AB, and we are going to find vector AC. For vector AB, we are going to take the coordinates of point B, -3, 1, and 4, and we're going to subtract them by coordinates of A, which are 2, 6, and -5. We'll end up getting -5, -5, and 4 minus -5 is 4 plus 5, which is 9. It can't be simplified, so if you ever get vectors that can be simplified, you can simplify them, but in this case we can't really simplify this because they can't all be divided by same value. Okay, let's go for AC. We are going to take the coordinates of C here, which are 6, -2, and 2, and subtract them by coordinates of A, which are 2, 6, and -5. We will get 6 minus 2, which is 4, -2 minus 6, which is -8, and 2 minus -5, which is same as 2 plus 5, which gives us 7. We can test this also to see if these are parallel or not, but in this case they won't be because we got -5 and 4. If we were to find a k value which is being multiplied by this, it would be 4k is equal to -5. So k would be a negative value, but in this case k would be a positive value. So they're definitely non-parallel, which is good. And the equation, we're going to use the vector equation, is going to equal to r. And we're going to use a point here. We're going to use point A's coordinates, and they will be the components of our position vector 2, 6, -5. And we are going to add that to some parameter. Let's call it t here. Vector AB, which is -5, -5, and 9. Plus another parameter, let's use lambda here, and let's do 4, -8, and 7. And that's one possible way of expressing the equation of a plane that contains these 3 points. So I will box my answer and highlight it as well. For our second question, we're asked to determine the equation of a plane containing the x-axis and point 1, 2, 3. It's always good to draw a visual to give us an idea, but what the question is asking. So we're going to have x, y, and z components here. So x, y, and z. And we know that our plane is going to go through the x-axis, which is this one over here, and point 1, 2, 3. So the point 1, 2, 3 is going to go 1 in the x direction, 2 in the y direction, and 3 in the z direction. So it's going to be somewhere here. I'm going to label that here. This is going to be point 1, 2, 3. I'm going to label it as A. Doesn't really matter what we name it, but the plane is going to look something like this. It's going to be out in space, and it's going to contain some point on the x-axis, and it definitely is going to contain this point as well. And yeah, and it's going to have this vector, and it's going to have the vector that starts, well, you can use any vector that starts from the x-axis. The easiest one to choose is the origin here, because the origin is actually on the x-axis, and I'm going to label this as O, or for origin. And basically we need, for this question, then we need a point. Let's choose the origin because it's definitely on the plane. So our point is going to be 0, 0, 0. And we need one of the vectors, which is going to be the vector from the origin to point A. So that's OA, that's position vector A. I will just write the answer fully here. So we need coordinates of point A, which are 1, 2, and 3. And we're going to subtract them by coordinates of point O, which are 0, 0, 0. And that's going to give us position vector 1, 2, 3. So that's one of the vectors that's on our plane, and the other vector is any vector that is on the x-axis. We can choose random points. I'm going to choose the easiest possible one that will have x value of 1 because it is on the x-axis, but it's moving 0 direction in y and 0 direction in z. So let's call that point B, and point OB here is going to equal to the coordinates of point B subtracted by the origin, and that's going to give us 1, 0, 0. Therefore, our final equation for the line, we already have two vectors which show us the direction, and we have a point. So our point is going to be 0, 0, 0 plus some parameter t multiplied by one of our direction vectors. Let's choose 1, 2, 3, plus lambda, another parameter, multiplied by another direction vector, which is 1, 0, 0. In this case, it's not a good thing to write the 0, 0, 0 as a point. Well, we don't need to because it doesn't contribute to anything. So we're going to just use t1, 2, 3 plus lambda 1, 0, 0. And since there is no point here, we are going to assume that it's the 0, 0, 0 point. So I'm going to highlight this, and I am going to highlight my answer. For our last question in this video, we want to determine the equation of a plane that contains this line over here, and it does not intersect the z-axis. Just like the previous question, we are going to try to draw this situation out to get a sense of what is happening. And I'm going to draw the x, y, and the z axis here. So we're going to have x, y, and positive z in these directions. And it is very difficult to draw these things in 3 dimensions, but after drawing them for a little bit, you'll get a much better sense of what's happening, and you might actually not need to draw anything for this question, you might actually right away imagine it in your mind and be able to actually start off the question. Okay, so in this case, we got a line that has a 0.70 -7 in it, and it moves in this direction. So let's label that point first. 7 in the x direction. Let's say 7 is this much. 0 in the y direction, so it's not moving anywhere up and down. And -7, +7 is in this direction, so -7 will be in that direction. So our point is going to be somewhere here. So let's label that as point A. Actually, maybe I'll just give you a little bit of, this is 7. Let's call this point point A. That's 7, 0, -7. In terms of our direction, it will go 1 in the x direction, 2 in the y direction, that's this way. Actually, 1 is small, 2 is this much, and -1, so it goes more in this direction. So let's draw that maybe. Let's use a different color. So that's 1, 2, and -1, so somewhere in that direction. So our line is going to go from the origin in this direction towards the direction vector. And we know that lambda could be positive or negative. So if it's positive, it will move in that direction. If it's negative, it will move in the opposite direction. And this line is continuous, so it will keep going on in this whole direction. We know that our plane is going to contain this point, but we also know that our contain will not intersect the z-axis. So if our plane was in the direction, let's say x, then it will be a plane kind of like this. And if it was like this, it will definitely intersect the z-axis at some point. If it was parallel to the y direction, then at some point when this line has gone all the way down, let's say to a point which is close to this axis, when we draw it upwards in this direction, it could intersect the z-axis. The only way for our plane not to intersect the z-axis would be that if it is parallel to the z-axis. So if I were to focus on the x and y axis of this, so let's say this is x and this is y, we know that the z-axis is coming out of the page here, so it's coming towards us. And if I were to draw the points just 7, 0 for the x and y, so x would be 7, y would be 0, and the direction vector in the x and y direction is 1 and 2, so it goes 1 to the right, 2 up. So it looks something like this, and my graph will look something like this. And the z-axis, if I were to draw it, it's just coming out of the page. So it's coming kind of like towards us. It's really difficult to show that, but imagine that it's coming towards us. And if this line over here, which is the same one as here, if it was parallel to the z-axis, or if it had the same direction as the z-axis, then it would be traveling in the same direction, coming out of the page in every point here. And the z-axis is also coming out of the page. So this line would never actually touch this z-axis. And the only way for this to happen again is if this line is parallel or it has the same direction as the z-axis. So how do we write the equation for this? Well, we already know 1 point on it. That's 7, 0, -7. So I'm going to write my r is equal to 7, 0, -7 plus we already have a direction vector, which is telling us the direction is in this direction over here. So let's write that down. That's I'll use t in this case. Again, it doesn't matter which parameters you choose or if you interchange them. I'm going to use t for this. plus we need one vector that is parallel to the z direction. And the z direction, if we want to travel in the z direction, that means we should not be traveling in the x direction, we should not be traveling in the y direction, so 0 in x, 0 in y, but we could travel in the z direction. We could travel by 1, 2, 3, 4, -1, -2, -3. Therefore, we can just use a parameter because we can multiply it by anything. 0 in the x, 0 in the y, but 1 in the z direction. And this would give me the answer for this particular question. Before ending this video, I just want to let you know that plane is a new concept that you're learning, and if you're having a little bit difficulty with it, just keep practicing and you'll keep getting better and better. Something with planes is that it is something that requires a three-dimensional knowledge, and for some of us that's much more challenging compared to others. So if that's the case for you, I highly recommend that you go to the 3D calculator on GeoGebra. I actually tried doing this last question using this calculator, but the application that I'm trying to use doesn't record what's happening on that website, and therefore I just couldn't use it, but I will put a link down to it. Please go try to draw draw this line, draw the plane, different planes, and see how it looks like in 3 dimensions. And if you want to use the plane function in GeoGebra, just type in plane and it will tell you the format that you got to put it in. And if you want to put a vector in, put vector and it will give you the format as well. Again, it will be very useful, and because this is the first video to the plane, I want you to get a good knowledge and foundation of it before moving on to the next few lessons. So please try those out to get better and better with imagining things in 3 dimensions. Thank you for watching the video.